Hey, welcome to the second video for section 5.1. In this video, we're going to be talking about intercepts, y-intercepts, and x-intercepts of a quadratic. The y-intercept is really straightforward. Nothing has changed from what you know. Y-intercept, we'll usually just refer to it as the y-int of a polynomial f of x equals a n x to the n dot 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 plus a1x plus a naught is f of 0 which equals a to the n 0 to the n plus dot 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 plus a1 times 0 plus a naught. And so all those zeros cancel everything out and we just get a naught. So our y-intercept is just that same as that vertical shift that we've seen before. So it's just a naught. Our x-intercepts are solutions to the equation f of x. Whoa, what happened there? Our solutions to the equation f of x equals 0. So when it comes to polynomials, these are also what we've referred to as roots or zeros of the polynomial. And we'll be very interested to find them, in part because once you have all the x-intercepts, you can completely determine the graph with just all the x-intercepts and one y and the y-intercept. In a sense, it completely determines what the polynomial is. And so in the following section, we're going to learn techniques to find the x-intercepts, but in general, this is what mathematicians would call a tough problem for polynomials of degree 5 or bigger, even degree 3 and bigger. For degree 2, there's the nice quadratic formula. For degree 3 and up, you tend to need to know something about the polynomial if you want to solve it. However, we often present polynomials in fully factored form. We might write it as x minus 1, x plus 1, x minus 2 squared. So that's an example of a polynomial that's in fully factored form. And then when we want a graph, we can just draw the graph. Sketch a little graph. We put our roots on there. So our roots are this one gives us a root at 1. This one's a root at -1. This one's a root at 2. So we just label -1, 1, and 2. Our leading coefficient in this fully factored form is 1. And our degree of f is actually just, all we have to do is sum up the degrees of each of these monomials. So it's 1 plus 1 plus 2, which is 4. So it's an even degree and it has a leading coefficient that's positive. So we know that the end behavior is going to look something like this. So that's from 5.1. And then we just want to figure out what's going on between -1 and 1, and between 1 and 2. Quick thing to do is to get the y-intercept. So that's f of 0, which is 0 minus 1, 0 plus 1, 0 minus 2 squared. So that's minus 1 times 4, minus 4. So we're down here at minus 4. And then we know we come back up to 1. And then we'll just check what's going on between 1 and 2. And you can do that by just plugging in one value, let's say f of 1/2, of 1.5. And that's going to equal 0.5 times 2.5 times minus 0.5 squared. So that's just plugging in 1.5 into our function. And that equals, for us, it's fine to just say some positive number. So it's something around here. And so our graph goes up and then down and then up again. It bounces when it hits 2. We know it can't be negative. We know it can't go up to this positive value, go back down to being negative, and then hit 2. Otherwise, it would have had another root, but we know all the roots when it's in this fully factored form. So this is what our graph is. And so this isn't a perfect sketch of the graph, but we can check it with Desmos and get an idea of if it was actually a good sketch or not. So let's do that right now. Share my screen and go to Desmos, graphing calculator. We'll just put in the quadratic that we had, x minus 1, x plus 1, x minus 2 squared. And so we can see that our graph that we had looks pretty close to what the true graph actually is. We kind of had a minimum down here at 4, and it looks like that's not actually the case. But our graph above between 1 and 2 is accurate, where it went to this positive value. It's a pretty good sketch. If you go on to take calculus, you'll learn all about how to find all the minimum values on the graph to really make the graphs look nice. All right. And that's all there is to it to intercepts. In the subsequent videos, we'll work on understanding how to find these intercepts.